say that Tesla is stealing water from the region.
This region has so much water. Look around you.
The local supply says there's no more water for the development stage.
No, this is completely wrong. It's like water everywhere here. Does this seem like a desert to you?
You might love your Tesla now, but after hearing this, you might never want to drive one again. Tesla loves to flaunt its sleek design, advanced tech, and that thrilling electric acceleration. But what they don't talk about, and the things they sweep under the rug, might just change your mind forever. Do you really know what goes into making your Tesla? The hidden costs of Tesla's batteries. The ugly hidden truth of Tesla starts with the batteries powering their electric cars. One of the main components of Tesla's batteries is cobalt. It is a mineral that is critical for stabilizing the battery and ensuring its longevity. But what Tesla does not often advertise is how this cobalt is sourced and the human cost behind it. Most of the world's cobalt comes from the Democratic Republic of Congo. It is a country rich in natural resources, but plagued by political instability and widespread poverty. In fact, around 70% of the world's cobalt supply originates from this region. This must be great for the battery industry, right? Well, not when you look closer at how this cobalt is extracted. In the DRC, cobalt mining often takes place in artisanal mines. These are small-scale operations where miners, including children, dig deep into the ground by hand, often without proper tools, safety equipment, or even clean drinking water. According to UNICEF, about 40,000 children work in mines across southern DRC. Many are forced into mining to support their families, working in conditions that would shock anyone with a conscience. The mining conditions are beyond hazardous. Workers risk their lives every day by entering poorly constructed tunnels that frequently collapse. Fatalities are not uncommon, but it is not just about accidents. Prolonged exposure to cobalt dust has been linked to serious lung conditions, and water sources near these mines are often contaminated with toxic substances. The more you hear the story of cobalt mining, the more disturbing it becomes. Research by Amnesty International shows that large tech companies, including Tesla, have been linked to these artisanal mines in the DRC. In fact, many of the world's leading vehicle manufacturers depend on cobalt from this region. While Tesla has made claims about ensuring ethical sourcing of their materials, investigations have shown that tracking the supply chain of cobalt is incredibly difficult. The supply chains are murky at best, with raw materials passing through multiple hands before reaching battery manufacturers. This means there is a high likelihood that the cobalt in your Tesla battery came from one of these dangerous, exploitative mines. It raises the critical ethical question: is an electric car, supposedly a symbol of a sustainable future, worth supporting these kinds of working conditions? Sure, you are reducing emissions, but at what cost? Let's talk in numbers. In 2023, global cobalt production was about 230,000 metric tons, and the demand is skyrocketing with the boom in electric vehicle production. A Tesla Model S, for example, uses around 13 kilograms in its battery. Multiply that by the millions of electric vehicles Tesla and other automakers plan to sell over the next decade, and you can start to see the scale of the problem. A study published by the University of California found that by 2050, cobalt demand could increase by as much as 585% due to the growing demand for electric vehicles and renewable energy storage. The DRC's cobalt industry is already struggling to meet demands without exploiting vulnerable workers. So what happens when that demand increases by 5 or 6 times? Some might think, why doesn't Tesla just switch to using something else in their batteries? It is a fair question, and Tesla has announced efforts to reduce their reliance on cobalt. For example, the company is working on developing batteries that use more nickel, which is more abundant and less ethically problematic. But for now, cobalt remains an essential component in many of the high-density batteries used in Tesla's cars. Until a breakthrough technology eliminates the need for cobalt altogether, we are stuck with it. The tech industry has been under increasing pressure to clean up its supply chains, and some companies have made moves in the right direction. Tesla, for example, has said that it audits its supply chains and ensures that cobalt used in its products is responsibly sourced. But reports from organizations like Amnesty International suggest that more needs to be done to truly eliminate child labor and unsafe working conditions in the cobalt industry. At this point, you are probably wondering, what does this have to do with me as a Tesla owner? Well, everything. The demand for electric vehicles, and by extension, for cobalt, has exploded in recent years, and it is not going to slow down anytime soon. As consumers, we have a role to play in asking tough questions and holding companies accountable for the choices they make. It is easy to get caught up in the excitement of driving a high-tech, eco-friendly car, but it is important to consider the hidden costs. By driving a Tesla, or any electric vehicle powered by lithium-ion batteries, you are part of a system that relies heavily on cobalt mined in unethical conditions. That's the uncomfortable truth. We live in a time where everyone wants to be more conscious of their carbon footprint and do their part for the planet, and electric cars like Tesla have been marketed as a way to achieve that. But if you are unknowingly supporting child labor, hazardous working environments, and exploitation in the process, are you really driving a clean car? It is not just about emissions anymore. It is about the entire life cycle of the product, from the moment the materials are extracted from the earth to when the car hits the road. And as long as cobalt is a necessary part of the battery equation, the ethical dilemma remains. And it is not just cobalt. Tesla is ruining our environment and our limited resources in many other ways as well. Lithium and rare earth metals. You have probably heard a lot about lithium lately. It is a crucial component of Tesla's lithium-ion batteries. Tesla hypes up its cutting-edge technology, but what they don't talk about is the environmental destruction and resource depletion tied to the mining of lithium. While electric vehicles are celebrated as a greener alternative to traditional cars, the production process, especially when it comes to extracting lithium, tells a different story. Now the thing is, Tesla cannot work without lithium. Lithium is a key ingredient in the batteries that power Tesla's electric vehicles. It is what makes the battery energy-dense, lightweight, and long-lasting. It sounds great for clean energy, right? Well, not when you consider how lithium is extracted from the earth. Most of the world's lithium comes from South America's Lithium Triangle, which includes countries like Chile, Argentina, and Bolivia. These countries hold over 50% of the world's lithium reserves. The extraction process, however, is incredibly water-intensive. To extract just 1 ton of lithium, nearly 500,000 gallons of water are required. In the already arid regions of Chile's Atacama Desert, this is causing a water crisis. Indigenous communities rely on this scarce water supply for farming and daily living, but now they are competing with massive lithium mining operations. In Chile's Salar de Atacama, lithium mining has consumed about 65% of the region's water supply, leaving local farmers and wildlife struggling to survive. A report from the German environmental organization, GNF, revealed that the mining of lithium is significantly depleting natural water sources, leading to soil degradation and loss of biodiversity. Indigenous communities have voiced their concerns, stating that mining has affected their access to clean water and has disrupted local ecosystems. Water is not the only problem. The extraction of lithium from the ground also causes substantial damage to ecosystems. To collect lithium, miners pump large amounts of brine or salt water from beneath salt flats, which then evaporates in large ponds, leaving behind lithium-rich salt. But this process is not eco-friendly. It disrupts the fragile balance of salt flats and destroys habitats for local species. In Argentina's Salar de Hombre Muerto, reports have indicated significant environmental changes in the region's water cycle, resulting in the loss of vegetation and wildlife. Lithium extraction has transformed once thriving ecosystems into barren landscapes, with long-term consequences that are not fully understood. The environmental footprint of lithium mining raises a tough question. Is driving an electric car really eco-friendly when its battery is wreaking havoc on the planet? the image of Tesla as a sustainable, clean energy company starts to look a lot less glamorous when you dig deeper into the cost of lithium extraction. Is your electric car truly green? We all want to believe that driving an electric vehicle reduces our impact on the environment, and in terms of reducing tailpipe emissions, it does. But if the production of that vehicle's battery involves depleting natural resources and destroying ecosystems, is it really a step forward for sustainability? It is a question we need to ask, especially as the world becomes increasingly reliant on electric vehicles to combat climate change. Tesla may claim that their cars are eco-friendly, but the damage done to communities in South America and the destruction of ecosystems suggest otherwise. When you are driving a Tesla, you are not just running on electricity, you are running on the backs of exploited resources and damaged environments. But then again, lithium is not the only concern when it comes to Tesla's batteries and electric vehicles. Rare earth metals are another key component of these high-tech machines. While they are often overlooked in discussions about electric cars, they play an important role in making those quiet, powerful motors hum. Rare earth metals like neodymium and dysprosium are essential for electric vehicle motors, including those used in Tesla's cars. These metals are used to create the strong magnets that power the electric motors, making them efficient and lightweight. But just like lithium, the extraction of rare earth metals is fraught with environmental and ethical issues. Most rare earth metals are mined in China, which produces over 85% of the world's supply. The process of extracting these metals is highly destructive. Mining rare earth metals involves using toxic chemicals and generating large amounts of radioactive waste. In China's Baotou region, home to some of the largest rare earth mines, the mining process has created a toxic lake where waste from the extraction process is dumped. Local residents have reported high rates of cancer, respiratory illnesses, and poisoned water sources. Rare earth metal mining is not just an environmental disaster, it is also a resource issue. As the demand for electric vehicles continues to rise, so does the demand for rare earth metals. And the concerning thing is that these metals are becoming increasingly scarce. The world's reserves of neodymium, dysprosium, and other rare earth metals are finite, and they are being rapidly depleted by the booming electric car industry. So what happens when we run out of these essential materials? The shortage of rare earth metals could have serious consequences, not just for electric vehicles, but for the tech industry as a whole. Everything from smartphones to wind turbines relies on rare earth metals, and without them, the production of green technologies would come to a grinding halt. This could also lead to geopolitical conflicts. As rare earth metals become scarcer, countries with large reserves like China will hold significant power over the global tech industry. We have already seen tensions rise over access to these materials, and it is not hard to imagine a future where nations go to extreme lengths to secure their supply of rare earth metals. But it is not just about scarcity. The environmental impact of rare earth metal mining is creating long-term damage to ecosystems, water supplies, and the health of communities living near mining operations. The more we rely on these metals, the more we are putting our planet at risk of environmental collapse. Now, looking at these facts, can you really say this is the future you want? The push for electric vehicles is often framed as a solution to the climate crisis. But if the materials needed to build these cars are causing environmental destruction and depleting Earth's finite resources, are we really moving in the right direction? Tesla and other electric vehicle manufacturers have built their brands on the promise of a greener future, but the reality is far more complex. The extraction of lithium and rare earth metals is creating a new environmental crisis, one that we need to address before it's too late. While Tesla is working on developing new battery technologies that reduce the need for cobalt and rare earth metals, we are still a long way from a truly sustainable electric vehicle. Until then, we need to ask ourselves some tough questions. Are we willing to trade one environmental crisis for another? And is the future of clean energy really as clean as we've been led to believe? Now let me drop another truth bomb here and bust those recycling myths for you. Recycling myths. So, you have heard about the environmental and ethical issues surrounding lithium and rare earth metals in Tesla's batteries. But what happens once those batteries reach the end of their life cycle? Many people assume that electric vehicle batteries, especially Tesla's lithium-ion batteries, are easily recyclable, and that recycling solves the problem of finite resources. Unfortunately, that's not the whole truth. The reality of battery recycling is far from the green image that Tesla and other EV manufacturers like to project. There is a widespread belief that the batteries in electric vehicles can be easily recycled, reused, and repurposed, making them a sustainable option in the long run. However, the truth is far more complicated. According to the International Energy Agency, IEA, only about 5% of lithium-ion batteries are currently being recycled globally. That's an alarmingly low number, considering the millions of electric vehicles already on the road and the even greater number expected in the future. You might wonder why so few of these batteries are recycled. The answer lies in the complexity of the recycling process itself. Lithium-ion batteries, especially the large ones used in electric vehicles, are incredibly difficult to recycle. The batteries are made from a mix of materials, including lithium, cobalt, nickel, and rare earth metals, all tightly packed together. Extracting and separating these materials is not only time-consuming, but also requires specialized technology and infrastructure, which many recycling facilities currently lack. Another common misconception is that recycling electric vehicle batteries is a clean and environmentally friendly process. In reality, the recycling of lithium-ion batteries can be just as harmful to the environment as mining new materials. The process typically involves shredding the batteries, which can release toxic chemicals and metals into the air and soil. Additionally, the recycling process requires a significant amount of energy, contributing to greenhouse gas emissions. A report from the U.S. Environmental Protection Agency found that the current methods used for lithium-ion battery recycling can produce hazardous waste and contribute to environmental pollution. It turns out that recycling batteries is not the magical solution we have been led to believe. In fact, the inefficiency of the process means that we are not recovering nearly enough materials to offset the environmental impact of mining new ones. Now, why don't we just recycle more batteries? Well, one of the main reasons why lithium-ion battery recycling is so challenging is due to the design of the batteries themselves. Unlike lead-acid batteries, which are commonly used in traditional gasoline-powered cars and are recycled at a rate of over 95%, lithium-ion batteries are much more complex. Their intricate structure makes it difficult to extract valuable materials efficiently, and as a result, many recyclers choose not to process them at all. To recycle lithium-ion batteries, the batteries must first be collected, transported, and disassembled. This process is labor-intensive and costly, and once the batteries are disassembled, the materials need to be separated through a combination of chemical and mechanical processes. These processes often involve high temperatures and the use of harmful chemicals, further diminishing the green credentials of recycling. Moreover, the economic incentive to recycle lithium-ion batteries is weak. The cost of extracting new lithium from the earth is still lower than the cost of recycling existing batteries, which discourages companies from investing in recycling technologies. This economic barrier means that many used batteries end up in landfills or are simply stockpiled for later disposal. Now, let's address the big question: what happens to all these batteries when they die? If only a small percentage of lithium-ion batteries are being recycled, where do the rest of them go? Sadly, many of them end up in landfills, where they pose significant environmental risks. When lithium-ion batteries are not properly recycled, they can leak toxic chemicals into the soil and groundwater, causing long-term environmental damage. The materials inside the batteries, such as cobalt and lithium, can contaminate ecosystems and pose health risks to humans and wildlife. And with the number of electric vehicles on the rise, this problem is only going to get worse. According to the Global Battery Alliance, by 2030, the number of used lithium-ion batteries could reach 25% globally. Now think about the amount of waste. Without quick improvements in recycling technology and infrastructure, we are heading toward a massive environmental crisis. There is no denying that the current state of lithium-ion battery recycling is problematic. However, efforts are being made to improve the process. Companies like Redwood Materials, founded by former Tesla CTO J.B. Straubel, are working on developing more efficient and environmentally friendly recycling methods. These companies aim to recover a higher percentage of valuable materials from used batteries, reducing the need for mining new resources. But these advancements are still in their early stages, and widespread adoption of improved recycling practices could take years. So, the question is, can we afford to wait that long while millions of used batteries pile up? Tell us your opinions in the comments below. If you learned something new today, make sure to subscribe for more updates. We will catch you in the next video. Goodbye.